Alright, so a functional group is an atom or a group of atoms that gives the organic compound certain characteristic properties. This is the chemically active part of the molecule, and that is the reason it is called as the functional group. Now we have some examples here. This is a molecule of methane. If you replace one of the hydrogen atoms with chlorine, you will get a totally different compounds, that is chloromethane. Now there is a complete series of these chloro compounds. You can have chloromethane, you can have chloroethane, you can have chloropropane, you can have all these different compounds: chloromethane, chloroethane, chloropropane. You can see just by replacing one of the hydrogen atoms, we can have a totally different series of organic compounds. That is why there is this diversity of compounds in organic chemistry. There are millions and millions of organic compounds. If you replace one of the hydrogen atoms here with the hydroxyl group, you will get alcohol. This is methyl alcohol. You can have ethyl alcohol, you can have propyl alcohol, etc. Just replace this Cl with OH and you will have methyl alcohol. Replace this Cl with OH and you will have ethyl alcohol, and this goes on like this. And in the third one, you have replaced one hydrogen atom with this carboxylic group, so you will get carboxylic acids. This is another way of classifying organic compounds. This classification is based on the functional group, and we are going to discuss different classes of these organic compounds in the later chapters. Let's move forward. Let us talk about a little bit about these aliphatic hydrocarbons. So, as we have already studied, aliphatic hydrocarbons are those compounds in which carbon atoms are arranged in the form of a chain. So they include open chain acyclic compounds and cyclic compounds having similar properties to those of open chain compounds. You can see there these compounds are classified into open chain and closed chain. So what are open chain or acyclic hydrocarbons? They can be straight chain or branch chain. In straight chain, in these compounds, no carbon atom is linked with more than two hydrocarbons. Each carbon atom is linked with two other carbon atoms. There can be no carbon atom which is linked to more than two carbon atoms. Branch chain, at least one carbon atom is linked to 3 or 4 carbon atoms. In this case, you can see this carbon atom is linked to 1, 2, and 3 other carbon atoms. Another classification of organic compounds is possible. It is based on the valencies of carbon atoms. If the valencies of the carbon atoms are fully satisfied, just like this, if all carbon atoms are forming single covalent bonds, then they are called saturated hydrocarbons. But sometimes there is at least one or more multiple bonds. So these compounds are called unsaturated hydrocarbons. Saturated hydrocarbons. In these compounds, all the carbon atoms are bonded together through a single bond. They are called saturated because all the 4 valencies of carbon atoms are fully satisfied. Saturated hydrocarbons are also called alkanes. In this example, in case of N-butane, this is N-butane. In this example, all the carbon atoms have 4 single bonds with their neighboring atoms. There is no multiple bonds. So all the 4 valencies of carbon atoms are satisfied. Every carbon atom makes 4 bonds. Unsaturated hydrocarbons. In these compounds, at least one carbon atom is bonded to another carbon atom through multiple bonds. Alkenes. If there is at least one carbon atom, carbon-carbon double bond, then it is called as alkene. Just like this, there is at least one double bond in the skeleton of the molecule, so it will be called as alkene. It's going to be unsaturated. It can be converted into saturated compounds. Another type of hydrocarbons is alkynes. I have forgotten to write them, so I'm going to write this now. Alkynes. In alkynes, there is at least one triple bond in the molecular skeleton. For example, you can have this here. This is an alkane. So if we replace these single bonds with multiple bonds, we can have this. Or let me draw it here. It's going to look like this. This is an alkyne. We are going to study each of these classes in a lot more detail in the later chapters to come. One more thing that I want to talk about is the homologous series. The homologous series are a group of organic compounds that all share the same functional group and have similar structural and chemical properties. Each member contains one methylene group more than its previous member. Homologous series are actually series or group of organic compounds. They have similar functional group. That is why they show similar chemical properties and similar structural features. For example, in the alcohol family, there are so many members. All these members have some commonalities. They have the same functional group as in methyl alcohol, ethyl alcohol, and propyl alcohol. And they have the same structure. So their properties are going to be similar to each other. Each member of the homologous series has an additional or one more CH2 group, which is called as methylene group. For example, in this case we have an extra CH2. Now methyl alcohol doesn't have this extra CH2. That is why it has got only one carbon atom and 3 hydrogen atoms. But ethyl alcohol has got this methylene group. In case of propylene, it has one more methylene group, and this goes on like this. So each new member has one more methylene group, and this is how an entire series of organic compounds is created. So I think this much is enough for today's lesson. In the next lesson we will discuss further. Thank you very much.